It's not turning.
Yeah, test.
Oh, yeah. All right.
Hello. Okay. We're going to start the final session for today. Shh. This works so well. Okay. Basically, the final session for today, because it's sort of Friday evening, and we're going to have a nice reception in the British Library soon, is a little bit more, I think, informal, and well, it's always been interactive, but even more interactive than usual. So we have a couple of people here who are going to talk about various sort of, things surrounding AI. So in particular, we have someone from Element AI, Julian, who will talk about AI for good. Then we're going to have Mustafa Sissé, who will tell us a bit about AI programs in Africa. And after that, we have from the Alan Turing Institute, there is a program, and I'll say the name completely correctly, Data Science for Social Good. And we have a bunch of leaders of groups for this program who are going to give us a quick overview of the work that they've been doing. The point of this is also that you'll be able to sort of ask questions and sort of explore ideas around this space. So Julian is going to tell what he has been doing, but you should also feel free to sort of ask him about these. We're going to leave a decent amount of time at the end for questions, comments, suggestions, all that sort of thing. So that's sort of the idea for this program. So first of all will be Julian. So Julian, he did his PhD in Paris. Then he went to UBC for a postdoc. Then he went back to UCL and did an even better postdoc because it's UCL. After that, he went to DeepMind, then left DeepMind for Amnesty, and then moved from Amnesty to Element AI. And he's in the London office. And the purpose of the London office is really focused on AI for good. So he's going to tell us a bit about the recent stuff he's been doing. So thank you.
Thank you very much, Arthur. I've got labeled. Hi, everyone. Really good to be here. I remember being in the audience 10 years ago and thinking, oh, wow, there's all these old professors at the front. And, well, guess I'm the one now. So in the next 2 hours, we'll be focusing on the convergence and the asymptotic behavior of callback library. No, all right. That is the kind of talks I used to give. My PhD and my postdocs, Arthur said, in this very noble institution, were all around the link between theory and algorithms. Now, what's really interesting with machine learning and computer statistics and artificial intelligence is that there is a thread from the theory to the algorithm to the applications. And back, the first steps of statistics were about applications. How do we keep count of the population in the countries? In this very establishment, you go to the statistics department, and there are the first statistics table around the causes of death in the UK. They're on display, done by Fisher back in the 1900s. And as I grew into my career, I realized, well, with all these cool tools, I was at DeepMind for 4 years. And the goal at DeepMind is, let's solve intelligence, artificial general intelligence, whenever that may come. And that's really great. But even there, I was thinking, how can we put all these cool tools that as a community we're developing, how can we put them to good use now? That's why I co-created the health research team at DeepMind. And then after 2 years of that, so 4 years in total, decided to see, can I go volunteer for Amnesty and help them? And this is a story of how that started by, I started to put a hand in the big machine of trying to do useful stuff. And essentially now, I'm still fully there, actually, full body. So, I'll start with 2017. I just left DeepMind, and I started volunteering with Amnesty International, bumping into them in a meetup. The nice part of such things like here today, you meet people. Look at the faces around you. These are the very same people you will keep meeting throughout your whole career. And that's awesome, because you will always remember how you got shit-faced in a pub in London. Now, this work was done with Milena. She's from Amnesty. She sends her apologies. She was supposed to present. Right now, she's in a dark room, in the quiet, with a massive migraine. So sorry, you're stuck with me for the whole talk, not half her and half me. So 2017, well, quick show of hands, and I expect given the audience, many of you will have the answer, and like many other audiences, which country is that? Who knows? Yeah, thank you very much. In past talks, I've heard Africa. No. So this is Sudan, and the region here is Darfur. And as you know, in Darfur, the problem is a conflict that has been going on for 15 years. This is a typical hut in Darfur and in this part of East Africa. This is a tukul, straw, roof, wood, and baked clay. And you find them in villages in the middle of Darfur in the desert, like this, clustered, surrounded by fences of straw. And the problem is this here. This is two Janjaweed, two soldiers, coming on horseback or on a jeep, setting fire to some of the tukuls, destroying part of the village, raping the women, spreading the population to the wind, and moving to the next village. And they leave behind them ruins. That has been going on for 15 years. It's been in the news. It's been out of the news. It's been back in the news. And Amnesty International, along many other organizations, have been trying to get impact on this conflict by different mechanisms that they are very, very good at. Some are producing reports showing what is happening behind these closed borders, because indeed, the borders are closed. Amnesty is extremely good at qualitative evidence. They send an email, or sorry, not an email, they send a phone. They smuggle a phone call from the top of a mountain on a satellite phone. They speak to refugees in the neighboring countries who cross the borders, those who could. They are able to gather what is going on and make pressure on the international stage to get action and stop the governments from keeping doing that. Not always successful. So they also collect evidence that can be later on used in a criminal trial. And they've been really at this for many, many years. When I met them in late 2016, they were starting to think that they could do even bigger than purely qualitative. So they have one expert, her name is Micah. She's a satellite imagery expert, and she looks at satellite imagery all day long. That's her profession. She has the most intricate visual cortex at Evernet. And she's been able to do a fantastic job looking at a few hundred square kilometers, doing some really important reports before and after. Here are the traces of a specific type of weapons in the Jebel Mara area. That has been really impactful, but she's only one. And so Amnesty, and Milena in particular, in 2016 turned to do the project called Decode Darfur, which is simple. Micah would write a tutorial that would be put on a website. Anybody could connect to the website and be shown a little part of Sudan and then click, label, where they see human presence. Because the first thing is that there is no map of Darfur. We know where the big town of Niala is, the different villages that are being destroyed. We don't even know where these villages were in the first place. So anyone could connect, be shown a part of Darfur without localization, so they only see the image 200 meters by 600 meters. They don't know exactly where it is in Darfur, and they click where they see human presence. And that allows to collect, several thousand square kilometers. There was a big campaign of advertisement in the Swedish Tube. Tons of people connected, 7,000 people participated. One person spent 70 hours in 1 week. Milena contacted her to check if she was trapped in a cave with just an iPad. She was fine, but what she was a woman in a wheelchair who felt that she could not participate in the marches. She can only sign petitions online, but there she had the opportunity to do something more useful. And this kind of crowdsourcing this aspect of crowdsourcing is quite important. As machine learners, you'll think, oh, that gives us data. But actually, as an activist, it gives you much more. It gives you many more people who feel engaged with the problem, much more than if they just sign a petition. So there's already this first aspect, which just by having this crowdsourcing aspect is already very impactful. And then it doesn't take much of a machine learner, when I saw that at the meetup, to say, well, hold on. The same way one expert trained a crowd, your crowd can train a neural network. Cue the mandatory picture of a brain with tons of electrics on it, but that's the essential idea, is that we move from several thousand square kilometers to possibly continent scale. So how did we do that? This is the website you would see if you logged in. You arrive, you see that, 600 meters by 200 meters, each tile is 100 by 100, and you click where you see a human presence. The most important part of this, beside the data collecting, is all the work that went into gamification, and most importantly, this little button, flag. You have a doubt, click on that, screenshot, automatically sent to the forum for discussion. You ask, hey, what is this? And Micah would answer. And then suddenly the crowd started to learn more and more, be more and more expert, and then the more people would connect, the more the first person to log in would have become expert and advise the next people who were logging in, and suddenly you have a crowd who has become a full expert on just this. And that is really important for the quality of your data. Moral of the story, when you are trying to do a machine learning project, the design is fundamental to get your data. And I'm not talking about design of experiments, I'm talking about user experience design. This is a tutorial that you would see. What you are looking for is this: metallic roofs, small roofs clustered together. You can see here the straw roofs of the two cool. You can see the fences around the two cools made of straw, as you see on the picture. And this is what you are not looking for. These are just trees, isolated, natural colors, bit of rocks. And this is what you see way too often. This is a destroyed village where you see there is no roofs, no more roofs. The shadows cast by the walls are much smaller. These are all signs that algorithms, especially computer vision algorithms such as deep learning, are extremely, extremely good at capturing. So this is a complete low-hanging fruit for machine learning. And the notion of low-hanging fruit is going to come back again and again through this talk. So we took that data set, and then with Daniel Worrell, who was also doing his PhD in UCL, on his night and weekends was volunteering on that kind of stuff. When he should have been writing his dissertation, that didn't work out too badly for him. He's now doing a postdoc with Max Welling, so he's okay. But importantly, that's where he stepped in and got involved in these things in the first place. The algorithm behind it, after these 2 weeks, all of you are able to do it. ResNet 50, fine-tuned from ImageNet to the tile that we had labeled. It's a binary classification problem. 4 classes if you add the destruction. And you use heavy data augmentation, rotation, elastic deformation. Those are really important. They're really efficient. All these kind of basic tricks in TensorFlow, and there we go. But then on top of that, it's very nice if you have an algorithm and you've got, I've got my test loss, it's really good. Yeah, a whole lot of good that does to Amnesty. You want a tool that the human rights experts can actually use. And this is where you put also your hat as dirty coder in JavaScript and try to make a web interface. So this is what I did. My colleague Jicha, who is now working on that, hates my guts for the dirtiness of the code, but at least it's a visualization that was interactive and allowed Micah and the human rights experts at Amnesty to see what was the output of the algorithm. So let's have a look together. This in green is the human labels. Every time they click, say human presence, there you have it. So this is a big town of Nyala. That's one of the few that is on the map. And you can see that could be London, that could be any city. Metallic roofs, grid-like pattern, a big park, even a river in the middle. The human volunteers also discovered these little huts in the middle of fields. And false positives, that's a field without a hut, shouldn't have been tagged. Or these are trees and rocks, shouldn't have been tagged. They also identified other villages like this one here, on one of the main roads out of Nyala, but more rural, so much fewer metallic roofs, still very dense, lots of greenery. And that's another type of village that they found. Take this and apply it to the full continent. And in red is the output of the neural net. And this is what we saw in 2017 before Facebook was putting the maps of countries online. And this in red, every human inhabitation we found in the region. So you see the urbanization pattern, free space around the villages. You do not need to build a hut, you can go back for the night. Find these villages in the very arid middle of the desert, quite different from those we trained. Find these little specks. Are these mistakes? No, they are actually huts next to what we believe are cattle trails. These can be huts for shepherds. So these are all the buildings we were able to identify. Of course, the next question is how well does that work out of sample if we go beyond Darfur? We applied it to the border between Uganda and South Sudan, and when I saw that, my heart failed. Okay, our algorithm failed. There's no way there's a big megalopolis here. If we zoom in, though, it is. This is just a different urbanization pattern with small cluster of huts all along the network of roads that crisscross this fertile region in Uganda. So that generalized pretty well. As machine learners, you'll ask me, show me the numbers. And this is the confusion matrices. So you can see that we are around 95% true prediction on the different classes, human presence versus no human presence, and here, destroyed versus not destroyed. I did not figure here the labels for destruction, but we also had them, although we had, I think, 8,000 labels only. Compare that to ImageNet, 1 million images. Data augmentation and transfer learning and fine-tuning here were quite key. Now, this is very nice, and I'll come back in a minute for why this was much less useful than what we would have hoped. But this, 2017, was already the moment where we thought, well, okay, 2 tech guys, somewhat part-time volunteers, and 2 great people at Amnesty, we already are opening really interesting perspectives. what would it be if we had a full team? So this is a point in time where I started to look, how can I fund a full team? And I found it when I met Yoshua Bengio at the UN AI for Good Summit in Geneva, at the United Nations. He had just founded Element AI. They had the desire, the values, and the resources to do AI for good. I had the desire, the values, and the ideas. I ended up opening the London office of Element AI, and especially the team on AI for good in there. And I'm putting AI for good because, as you'll see later in this talk, there's a question about what is good, and who are we to define what is good. Fast forward a year. Now I have a full team, and we're working with more people at Amnesty and with other NGOs. I grew the team from 1 to 12 by the end of 2018, and this is what we worked on for a lot of 2018. This is a project called Troll Patrol, completely different from Decode Darfur, but with the same thing. You take domain experts, you take tech experts, you put them together. This is to study the abuse against women on Twitter. Here are all the Twitter feeds of my colleagues who worked on that. Follow them on Twitter, like, subscribe, etc. Trigger warning, the next slide is going to show some real, very abusive tweets against women. If this is a trigger for you, please just don't look away. I'm not going to read them loud. But this is the real tweets found on Twitter by Amnesty addressed to some of the female politicians in the UK. You can imagine the impact that this has on any one individual, which is in itself terrible. And in addition, you can imagine the impact this has on our democracy. When you have all these women journalists or women politicians that have to step out of a race because of the pressure that they are getting under. And you have seen Donald Trump's recent tweets, again, against women of color, politician women of color. This is a problem that is deeply rooted. And Twitter can be fantastic. It helped Mark and Arthur unlock some of the visa situations here. But it's also a tool that can do that. So we studied with Amnesty these kind of examples. What did we do exactly? It's a mix of computational statistics, machine learning, crowdsourcing. Again, the same recipe. Build a data set of tweets with a machine learning pre-filter, a naive-based classifier, to try and rebalance the classes and enrich the database in abusive tweets so that you lower the variance. But you use important sampling to make sure that you are still unbiased. There's also the side effect of driving engagement. If when a volunteer connects, 98% of the time they don't see abuse, they'll be asking, hey, what am I doing here? So you can rebalance that using important sampling and still have a proper statistical estimate. Crowdsourcing, then you do the data analysis on top of that using Bootstrap so that you get proper confidence intervals and that when Amnesty reports a number, it's not a number that is actually between 10% increase and 400% increase. No, it's a number that is, it's between 80 and 85% increase. Okay, I can build a report on that. Then, in addition, we also trained, and that's kind of the cherry on the cake, if I were to quote Jan, this is training a deep model on this gathered and labeled data set. And see, how good are the algorithms? Because don't believe the hype. It's not, we're going to show that algorithms solve that. No, it's how good are they? We compared Jigsaw perspective, we compared naive-based classifier baseline, a few others, our own algorithm, which is an extension of BERT with enriched dictionary, trained on this data, and we showed, actually, we got an F1 score. We beat everyone. We had 0.50 F1 score. Jigsaw is at 0.497 F1 score. We're all very close, but that's not enough. Tech is not a solution here. It can be a tool to help train human moderators, but that's all it can be. So let's put things in perspective. And eventually, Amnesty wrote with us this really deep, carefully reported report, eventually, that you can find online if you look at Troll Patrol findings. And they went public. And that's, again, Amnesty's skills on going public and getting a lot of engagement. What happened? Next night, so that was the 18th of December, within days, massive coverage across tons of newspapers, Bloomberg, MIT Tech Review, Wired, The Time, and a few others. And that goes this. This is Twitter stock. We came public here on the 18th of December, and this happened. Minus 13%, that's $2.5 billion of Twitter market cap. Now, I'm not in the business of destroying corporate value. I mean, not on my work time anyway. And they recovered. They're fine if you have a pension fund. Well, probably too young for that, but when you have a pension fund that has Twitter stock, you're still fine. They're recovered. But why does that matter here? It matters because this takes the issue at hand into a language that the execs and investors and shareholders of Twitter understand. That triggered having Jack Dorsey, the CEO of Twitter, talk with Kumi, the Director General of Amnesty International. That triggered the machine learning team in London reaching out to us. And we believe that this has triggered to Twitter trying to be a little more vocal about the problem that they have in a way created. It's not a done deal, it's not a solution, but it's a kind of impact that when you put, again, tech and domain expert together, you can get. Now, remember I said that Decode Darfur did not have the impact that we wanted. Why? Because all this imagery was not one-time snapshot. It was a collection, a mosaic of different revisits over 10 or 15 years. This is good as a proof of concept, but we want to take things beyond proof of concept. Proof of concept, student projects are fantastic. They stimulate the imagination. They create possibilities, but we want to take them further. And what's the problem? If you want one snapshot of high-resolution satellite imagery, it's $4 million for Darfur. 500,000 square kilometers, $18 per square kilometers. Hey, okay, you're an NGO, we're going to be nice, 55% discount, only $4 million for one snapshot. That doesn't work. The math doesn't add up. Amnesty does not have that kind of cash lying around. So how do we go about that? And that's why it brings us to last month. There's all these public satellites launched by the European Space Agency and other national space agencies. They are public, they are free, the imagery is free, but they are low resolution. You saw for the one you see on Google Images or Google Maps or Bing, and you zoom in, this is 30 centimeters for each pixel. Here, this satellite, Sentinel-2, is 10 meters per pixel. You do not see the tuculs. You can possibly see the shape of a village, but that's harder. Well, there's two ways here. Either we can, activate the business side and try to get co-partner projects and try to fund things jointly and find funders and raise $4 million times a multiple to have multiple snapshots, and that's one area we're exploring. But there's another one, which is try to see if we can do something with low resolution. That's where the European Space Agency launched a contest, a competition that ended on June 1st, and in which our team in London and the Mila team in Montreal, Joshua's lab, joined and applied. And this is a competition on satellite super resolution. I mean, you've all seen, no, I took it off. Anyway, you've seen the TV shows about, hey, can you enhance, zoom and enhance, in CSI or whatever. This is TV show. In reality, there is no signal in the image to do that. You are going to hallucinate details. That's fine if you want to super resolve, say, mangas or animes or cartoons. That is not when you are trying to collect evidence of human rights or environmental violations. You need to be a little more accurate. You can't make stuff up. So when ESA asked, can you enhance, we answered with this. This is multi-frame super resolution. You take multiple low-resolution images, then there is more signal. They're not quite aligned. The subpixel variations are so that you can actually rebuild more information out of it. So this is the architecture we did. I'm not going to go in detail there. The code is online. The blog post is online. The preprint is coming soon. Shoot me an email if you want the different links. But essentially, take the multiple low-resolution images with the median, fuse them together in a bunch of recursive fusion, upsample in the end, and decode, and you've got the super resolved image. What does that look like? Well, first, that looks like this competition where we topped Team Rarefin, we topped the public leaderboard, and in a dramatic turn of fate, on the final withheld results, we came second instead of first. That broke our hats. No, it did not really, because the first team anyway is an academic team entirely specialized in image processing, purely that. We're specialized into trying to take whatever is the current machine learning and the low-hanging fruits and the future low-hanging fruits and bringing them to fruition now. So we're still pretty proud of that. Now, more importantly, this is a high resolution. This satellite, that 300 meter per pixel, it's called Probavit, monitors vegetation, and this is what it captures. Now, the problem is it only visits every week or every 3 weeks. Not quite the kind of revisit you would need. Instead, we take one low resolution image, and another, and a few others. And these are available every day. And when we merge them together using HiResNet, we get this. And you can compare this super resolved output from true high resolution. If we zoom in, if you try to count the fields and the crops on this low resolution, that's going to be pretty difficult. You can actually do it pretty well with a super resolved image made just out of low resolution. And you can compare that to what you would be able to do much less often at a more expensive cost with the actual true ground truth high resolution. There's a few other examples. This is great for agriculture monitoring, land management. You can do the same again if I zoom with this, counting the fields here. Again, the low resolution, hard to see anything. On the high resolution, you can actually start counting the fields. You see the rivers, you see the roads. And this is to compare with the real, again, expensive and more rare actual high resolution. You can also use that for limnology, which is a funky word for water management. I learned it on Wikipedia when preparing the slide. But this is inland water management. Again, here on the low resolution, you know there's a river, but good luck trying to get any information as to the state of the river. On the super resolved, now you can follow the path and try to see how much water there is there. And this is to compare with the actual high resolution. It's not as good, but it's already done more useful than the original low resolution. And this is one possible way to make this kind of satellite technology accessible more directly to NGOs. And of course, the question is, why don't we learn directly the prediction of the volume of water from the low resolution? Yes, we can. That's where we want to be in the end. But if you want to have the human labeling of this low resolution, they're not going to be able to label squat on this. If you want to show for interpretability and for concrete proofs in a court of law, something that a human eye can interpret rather than a black box that outputs just a volume of water, well, again, you're not going to be able to do it just from that. So that's where the use of super resolution goes. Which brings to the next question in the next 5 minutes. What is good? And who am I to know what is good? And who am I? Let's be frank. I'm a white male in my 30s, in London, behind a laptop, looking at a problem in Sudan. Yeah, there's a name for that. That's called white savior, and we all hate that. How do we avoid that? So let's look first at this really important quote. Technology is not a solution. It's only a magnifier of human intent. Let's think of it as the society, the different incentives we have are a loss function, and with technology, we have a really, really good optimizer. So we're going to zoom in directly on the part which brings us the most reward for the incentives given by society. Yeah, and that's called, selling advertisement or videos on YouTube and getting you completely hooked on just staying on YouTube. Sorry, Mustafa. Now, that again, tech is not a solution. Fantastic tool and a magnifier. The good news is that we're not the first ones to go in there and saying, hey, we're going to do good with our tech. There is 30 years of information and communication technologies for development. I encourage you to read this book called Geek Heresy by Kentaro Toyama, and there's a ton of examples of things that went wrong. How many of you are from Kenya? Okay, so you might have seen the play pumps, which was something done in the early 2000s, a water pump where instead of having to pump manually in rural areas, you would have kids play on a wheel, and that would bring the water. Now, it turned out, sounds like a great idea from Silicon Valley. Yeah, kids going to help, and their mommies, and everyone's going to be happy, and the women won't break their backs to get access to water. Yeah, the problem is physics. Physics, if you use the spin of the wheel to get water out, the wheel doesn't spin as fast. The kids don't want to play. The women are forced to sit and play like kids on the wheel. It's humiliating, it's degrading, and eventually it's a complete failure. And there are many years of projects, the One Laptop Per Child initiative, the phone kiosk in Kenya. There's a lot of failed ideas that were designed really great by technologies very far from the actual problem, and that fell flat. We can learn from that. There are tons of pitfalls. We can analyze these 30 years and learn from both these failures and from the successes. And one key thing is, let's partner hand in hand with the domain experts. I'm a scientist. I have opinions how the world should work, but so does everyone at the pub. Now, there are people who spend decades studying the different problems. They know how to get some impact. They don't know what tech can do, but they know that if you speak to this person or if you make this kind of noise, for example, again on Twitter for visas, or if you do, you get traction. Let's work with them, and let's put our tools to their service and partner and discover together where tech can help. And that's where the low-hanging fruit comes again. Start with the low-hanging fruit. Computer vision is about as low as it can get these days, and start working on something together. And then they learn your language, you learn their language, and as you go, well, suddenly you're, oh, when I came to see you in the lab, you were playing with an algorithm that was doing that, but I have a problem that has something like this. And then you get to the next bigger thing that has a bigger impact. And sometimes you even just land on impact that you were not even expecting, as we did with Troll Patrol. So this is really the key. Partner with domain experts. Being in London, for me, it's easier to partner with Amnesty International, with Human Rights Watch, with some UN agencies. My dream is to be able to partner with people on the ground. And even better, my dream is to make myself useless and have people like you who are on the ground to develop these methods, to take them bigger and to work there on these problems. And that's why I'm thrilled that Mustafa is presenting afterwards about his program around machine intelligence, masters of machine intelligence in Africa. This is what we need. Now, the problem when working, going with partner, how many of you know XKCD? Yeah. So this is exactly the problem. You go in and you're going to solve it with algorithms. And that doesn't work because the problem is bloody hard, but then you can say, hey, at least now we know it's hard because I tried. Now that's the exact way you don't want to do it. Instead, there's a few bunch of steps you can take to have a good success. So how do you navigate? This is the one slide that you might want to photograph at the end. What is the path from concrete impact? Don't get fooled into measuring everything and trying to predict everything, but if you go with a partner who has a good track record of impact, on average, you'll have a higher probability of getting a good impact with your project. And that's again where having people who are on the ground, yeah, you're much more likely to have a good impact when you work with them than with someone who has never set foot in Africa. Get rid of the hype. AI, machine learning, yay, super excited. Well, sometimes AI just doesn't work. That's what we showed with Troll Patrol. It doesn't work enough, but it has a role to play. Just let's be clear about what we can do, which is really exciting, and what we cannot do, which is really important to emphasize as scientists. There's no, again, try to avoid the tech savior as in XKCD or the white savior. Identify the right depth of tech. Why would you go for a neural net if a plain linear regression can do? Use the right tool. There's a hard question for researchers here. Are you in this to solve the problem or help solve the problem? Or are you in there to illustrate your really, really cool and really powerful method? Don't get me wrong, both are right. There is a room for both of them. But you want to have people in the room who can take this method, but who can also take any other method in machine learning and apply it. Again, finding the right depth of tech. As long as we're clear about who brings what to the table, then the work is healthy and can work. And most importantly, and these are, you've seen here a few examples. You'll see Tom of really, really cool examples from the students and the fellows at DSSG after Mustafa's talk. But how do you plan for scale and sustainability? How do you go bigger than a proof of concept? In a way, there's a hackathon syndrome. Great hackathon, you feel good, but at the end of the weekend, that's where it stays. You put the source code on GitHub, you donate it to the community, and it stays there. And sadly, GitHub is the biggest cemetery of great ideas and great projects. How do we go beyond that? Where are the engineers, the designer, the UX design? How do we make that into bigger products? And this is where I want you to start thinking when you are starting to tackle these the things. Now you can ask me, okay, that's all very well, but I'm in my PhD. How do I get involved, and how do I plan for finding tons of millions of dollars and making a global service and whatnot? Now you might remember seeing that last year, these kind of headlines: the Facebook employees rioting against Zook, the Microsoft employees doing an open letter against the bidding for government contract, the Google employees who resign against the same government contract, the demand on transparency over Project Dragonfly, or the walkouts in different buildings in Google, where actually, fast forward to now, the person who led these walkouts have now had to leave Google, given pressure by her superiors. Now, you've seen all of that, and it can be summarized into these fantastic New York Times articles, which are, tech workers now want to know, what are we building this for? And here I'm mentioning Facebook and Google, but they're just the biggest ones. We're a small startup, we haven't crossed to that stage yet, but any big organization, if you're not careful, will fall into similar traps. How do we change that? Well, I mean, there's a report by some of my colleagues at Element which was looking at how much talent there is in machine learning and statistics and AI and whatnot. And it's a tiny, tiny number, a few thousand. Maybe by now it's possibly 100,000 thanks to people like you who are studying. But it's still very small. And your skills are in really high demand. So what can you do there? How can you use that? That puts us, as a whole, as a community, in a unique position to try and get change for our employers. I'm not saying go all working at Amnesty. First, they don't have positions open. Second, they have a budget crisis. And third, it's only one organization. Even our team in Element, we are only one team. Imagine what this could be if every single company who has tech people was putting some time of their employees, and I'm talking 20% time, I'm not talking 1 week every year. I'm talking serious time and resources of trained professionals, not just student volunteers, to solving these kind of problems, or more precisely, to putting the solution to these problems into the hands of those who know about these problems at a global scale. Now that would be really powerful. You can achieve that. You can do so by speaking with first voting with your feet. Which company, tons of companies are trying to get you now, which company has the best initiatives around that space? And look under the hood. I mean, yes, okay, there's a fund for projects and they are for good grade. Am I going to be allowed to spend actual time working on this project? Ask the question. Do your due diligence. You're smart, you can dig. Ask. There's tons of companies that want you. It'll be good actually for you to ask. It'll show you think ahead. First thing. Second thing, once you have a job, demand. Demand to work on this project. Ask, argue. Don't just make a nuisance of yourself. I mean, I love to do that, but you don't have to. You can also phrase the problems in terms that make sense for the company. I mean, I'm going to be very cynical here, but saying, well, if you have your employees who work on these kind of problems, they will want to stay longer because they're interested in their job. Or we will be able to access markets that we would have been ignorant of otherwise. Or we will be able, there's tons of reasons that you can put forward. Even, it make hiring easier. If you want to be cynical, or if you want to express these actions in the same loss function that is used by the key stakeholders and shareholders of companies, you realize there is a way to try and align. But it only happens if we all try that. Now, remember, you are the talent now and for the years to come. You can already volunteer. Datacan.org does some kind of volunteering and hackathon, and that is great. And they need more people, so you can go there and register. But most importantly, demand to work on this on your place of work. Thank you very much for your interest.
Thank you, Julian, for that really inspiring talk. So I think we have time now for some questions and discussion with Julian.
You're basically saying the only way to control big tech companies and force them to work on projects is actually relying on people inside.
No, sorry, go ahead, Fini. I didn't mean to interrupt.
Well, basically, governments are there for that. I understand the government does law and etc., but basically, de facto we are saying okay, democracy is too slow for doing this, and only tech company workers take care of this.
I'm really glad you're asking it. So the question is, hey, are you saying that the only way to fix is by people on the inside and democracy cannot work and government cannot regulate? Actually, I'm saying one way is to have people internally work on that. But if you look, Element is amongst one of the organizations that is demanding more regulation, and regulation with teeth. I'm really glad to be operating in Europe where we have GDPR. It's not perfect, but it's already a start. We need, and I'm entirely right with you, we need really strong regulation with severed teeth to pay really big fines. Facebook paid $5 billion in fine last week. That's peanuts for Facebook. That's about a week of salary. It's nothing. We need to have bigger regulation. And for that, that's another way you can be involved, is bringing your technical talent into the discussion with policymakers. There are a few people who are starting to do that, and we need more of that. But yeah, I entirely agree with you. It doesn't come only from the inside. The inside is how to do some stuff. The external regulation is how to make sure that whatever else is done, not just with the for good side, is actually kept in check. It's an excellent question. Yes, yeah.
You touched upon how do we define good, and this relates to the remark made about the issue of the modification of those water pumps in Kenya, and it touched on the question of how do you define better. So how do you define that you've done something better for the problem? Is this something when, in particular, you're working Element AI and potentially other companies who do certain things to Amnesty International? Is there a set out goal for each task? Because the task you commented upon about, let's take for example the satellite imagery, you kind of, okay, I've got this technology, I've given it to you. Do you just leave?
No.
So how do you find better? Because how do you avoid the same, it's a coarse analogy given that the pumps one, they took an existing technology, made it worse, kind of like, you know what I mean? But how do you define better? How do you know that you've done something better, and how do you plan to make sure you don't repeat those certain things, given now you're using more technologies to augment the problem as opposed to physical changes?
Excellent question. I'm going to repeat it for the live stream. How do you define better? How do you know that you have actually had an impact and not made the problem worse with your technology? Essentially, this is precisely why we work with domain experts. People like Amnesty, but also people like Greenpeace, people like, they have quite a clear feeling of what is better and what could be wrong. It's not perfect, but on average, they're getting a bigger score in terms of doing things better. In our case, when we work with Amnesty, we have signed with them a multi-year pro bono contract to be sure that we can keep helping them on different problems. That's why we're revisiting Decode Darfur. I did that as a volunteer. Now we're working on that within the company with more resources because we want to take that to the finish line. I want to move from projects to products. A tool that is reusable. There are many, many similar users across many different NGOs and international organizations, finding objects on satellite imagery. You have that to find tons of things for NGOs. We want to take that into a reusable platform that can be reused by all of them without us having to hold their hand. That's how it scales. We also want to be very careful because the same way you can find things for good, this is dangerous technology about surveillance. We thought hard before releasing our code from the competition for the European Space Agency on super resolution. We decided to do it in this case because it's a competition. Other teams have done really well. These tools are going to be out there. If we don't publish it, we'll be out of the loop. We'd better be in the loop on that. But we've released only the code of the competition, simple version of it. You can reproduce the results, but it's not a package that just suddenly magically works. For Decode Darfur, we did not publish the tool. We have a paper that says roughly how we do it, but neither the tool nor the data set are public. Too dangerous. Troll Patrol, Amnesty has decided that they will release the data set anonymized. And after only per approval, so you have to contact them to ask for the data set so that it does not get used to do more abuse. There's all these questions, but that's again where we need the partners. For the next question, sorry, could we have a question for a lady? Because we've got mostly male asking questions. Is there a lady in the audience who would like to ask? And go ahead. Don't be shy. All right. Yeah, thank you, please. Thank you.
So, how do you deal with resource constraints in the organizations that you work with? I imagine that Amnesty will not have a supercomputer that they can...
No, they don't. So the question is, how do you handle resource constraint when Amnesty doesn't have a supercomputer? As a volunteer, I use my own GPU machine at home. Now we have bigger resources at Element, and the idea by setting this team at Element is that the whole company can help. On Troll Patrol, we had someone from our NLP team who usually works on insurance products helping with the modeling. We use a cluster there. We use, when we work with Amnesty, we use our designers to come and think of ways where AI can potentially help in the framework of human rights. We have all the resources of this organization who come and help. We're a small part of a much bigger organization. Element AI is 500, we are 12, but we can tap into the talent of everyone. It's a beginning. We're looking at how can we take that to a bigger scale, but it's already way bigger than we were a year and a half ago, and I'm really hopeful for the future. Yes, please? So in the back, then in the front.
So you mentioned two really inspiring projects already. I'm wondering if you have any advice for someone who would like to make a positive contribution to the climate crisis, both within our field, so say maybe less flying to loads of conferences and wasting energy on training models, but also outside of the field of machine learning.
So the question is, what would you recommend to someone who wants to have an impact on, a good impact on climate change, both using ML or not using ML? Well, the first thing is, everything I've mentioned here was around human rights because I know Amnesty well, but we're also working on environmental applications, of course, and we started where we knew we could have immediately an impact. Climate is a bigger one, but it's where we're putting our path. That's just for us. There's a fantastic paper that came out, 97 pages, 600 citations, which is called Machine Learning for Climate Change, signed by Joshua, by Demis, by Andrew Ng, a ton of people. And they take systematically different areas of the fight against climate change and look at what is the potential of machine learning for this. So that is, I encourage you to look at that, be inspired by these examples. And they asked a lot of domain experts. It's not just machine learners thinking about ideas, it's actually validating them with domain experts who check, yeah, that makes sense, no, that doesn't, etc. So that's another way you can start to look at that. It's about 100 page, actually 45 pages of text, really, and then the citations. Have a first look at that. Then on the bigger question about environment, I wish I knew. I'm going to cite one person I really admire, David Mackay. He used to be a brilliant machine learner working on neural nets and Bayesian stuff in the 90s. Then realized, hey, with my skills I can do better than that. And he went into trying to look at energy and renewable energy and removing all the adjectives and replacing them by numbers so that we can think concretely. There's a fantastic book. It's called Renewable Energy Without the Hot Air. It's available for free online on his website. Sadly, it's passed away, but the website still lives on. It is a fantastic way to get to grasp about the different challenges that we are facing. It's about 5 years old, still pretty darn accurate, even though it does not mention data centers that much. And a final question before Mustafa.
So probably we should.
Yeah. Okay. Let's move on. Okay.
Yep.
I'll be there for the party, the reception at Microsoft.
Yeah.
And
So
the
everyone
rest
will
of
be
the
at the
evening.
Microsoft reception, so there will be lots of chances to ask further questions. So yeah. So.
Oh, sorry. You want the microphone? And you're back.
I think I'll just use this. It's fine. Yeah, that was Julian sabotaging the Google talk.
I'll just say, I think everyone here knows Mustafa, so he's head of AI in Accra, and he was also the founder of the AI Machine Learning Masters program. So he will tell us a little bit about the Google AI work he's doing.
Hi, so thank you, Archer, for having me here. And I'm sorry, everybody, I was supposed to be here on Wednesday, but the consulate decided to keep my passport until yesterday. So I got my passport back for the visa yesterday morning, and I jumped in the first plane yesterday evening. I arrived this morning, and here I am listening to Julian saying bad things about us. Sorry. No, but seriously, I have all the sins. I'm a male. I'm not white yet, but I used to work for. I used to work for Facebook. Now I work for Google. I have so many sins. But I think, with all this load, you still can do good things. And I came to this realization a few years ago. After graduating from my PhD, I went back home. I was with my mom, and we met one of my old friends, and who knew that I got my PhD, so he called me doctor. And my mom asked me, actually, why is he calling you doctor? And I was like, I'm mom, because I had a PhD. And she was like, I hope this doesn't make you feel as important as the actual doctors. So I was like, what are you talking about? I was like, be humble. You're not a doctor. So, when you acquire certain skills, it's good to do some useful things with it. And that stuck somewhere in my mind. And throughout these years I've been doing machine learning. That's what I've been doing for a long time now. Actually, I started doing machine learning 10 years ago, actually a bit more than 10 years ago. Back then I was studying math and physics. I was in Senegal, and in one of the algorithms course we had a project to do, and I wanted really to do something to actually build an algorithm that learned by itself, not just a set of if-then-else rules. And I started research about the topic how to do that, and I found the right tools on YouTube. So, and 10 years later, here I am. Anyways, so why am I saying all this? I am saying all this because I think what Julian said is actually pretty accurate. You all here have a very, very rare skills. I think it has never been this valuable to be able to train linear regressions. In the history of the world, people pay a lot of money for people who can do it. So keep regularizing. And so you can do great things with it because the time is ripe for it. There's a lot of data available which you can use to do great things. There's a lot of compute, and there are important problems to solve. And you are today in a position where you can decide what you will be applying your skills to. And that's what I decided to do a few years ago when I decided to go back home, literally. I was working at Facebook, and I think the first time I discussed this publicly was when we met in a conference in Geneva, the same conference where Julian met people from Element AI. So I left, and then I decided to go home, and because I knew people, and there was an opportunity to do this. I took a position at Google to open this new AI center in Accra, and at the same time, I took a faculty position at the African Institute of Mathematical Science to start a new master's program. So normally, when I give this talk, I just come and talk about all the great things you can do with AI. This is my team, by the way. They're all really great, and they work 100% of their time on AI for good challenges. And typically I come and talk about everything they do, work in agriculture. How do you apply AI in agriculture, or what you can do to bridge the communities and break the language barriers by training models to do natural language understanding for the 2,000 plus languages we have in Africa. I mean, in Europe, you have about 350 languages. In Africa, we have more than 2,000 languages, and a lot of them have more than 80 million speakers. And until now, we are calling them low resource languages. I mean, I will not, if I start this discussion, I could spend an hour here, but normally I would also tell you about a lot of great work that is being done at Google on disaster prediction, flood prediction. Now we have tools that integrate machine learning and hydrology, and we can tell you if the area in which you are will be affected by a flood and when, so that you can leave early. Typically, I would tell you about this, how it is deployed in an app. I would typically also tell you about the recent advances in health informatics, right? How we use machine learning and computer vision today to diagnose, for example, diabetic retinopathy, which is the fastest growing cause of blindness, and how this is important in areas like Africa, for example. I will tell you how we train neural networks, all these things. I will tell you about fairness and transparency, which is something I'm extremely excited about and spend a lot of time my own research doing, and which is very important. But Julian's talk gave me ideas. I think it is important to discuss how we can have better impact with everything we learn, right? With machine learning, with computer vision, or AI, or how it is called today. And the best way I have found to have that impact is to scale the number of people who have those skills. Because I strongly believe that if you put the right tools in the hands of the people who have the challenges, they will figure out the solutions by themselves. And the report that was produced last year by Element AI actually shows this very well. There is a huge gap between where the talent is, the talent pool of machine learning today, and where the challenges are, right? So we have a lot of expertise in North America, in Europe, and in certain parts of Asia. And while these skills are being used to solve important problems, I believe as a community we could have a much, much bigger impact if we had the skills transferred and evenly distributed everywhere in the world. And for this reason, I started what is called the African Masters in Machine Intelligence at the African Institute of Mathematical Science. It was quite an adventure. In fact, the first cohort started last September, but the whole work about this started way before. And it happened only because people like you, like Archer or Mark, who was here the whole week and who's I think just out for some reasons, contributed their time, their expertise, and committed to make this happen, to travel down in Kigali in Rwanda, because that's where we did it the first year, to teach the courses. We had foundations of machine learning courses, kernel methods courses, graphical models, optimization, and every course was taught by the leading experts in the field. And 10 months down the road, we have students who graduated before joining the program in mathematics, computer science, electrical engineering, but who were not doing machine learning, who now can sit in an MLSS. If you are from AMI, please raise your hand. And now they are interns, residents, engineers at Google, Facebook, Milab, Qualcomm, in all these places, and they will tomorrow be, I hope, lecturing in this program as well, because this is how we scale the population of machine learning researchers and engineers who will demonstrate impact in the most important challenges in the world. So I was supposed to actually talk about all the research we do on AI for social good, but I decided to use this time to promote this program and to recruit you, each of you, to come and actually, I think you know this person. She was around the whole week. And I want to show you just a short video about the program.
My name is Sarah Ibrahim. I am from Egypt. I have a master's degree in computer science, and I have also another bachelor degree in Arabic studies.
My name is Al-Tayyib Ahmed. I'm from Sudan. I did my undergraduate at University of Khartoum. I did it in electrical and electronic engineering. I specialized in software. In my final year of my undergrad, I did a project on creating smarter traffic lights, and that was my introduction to the field of machine intelligence. So I used different kinds of machine intelligence in that project.
My name is Niao Jonas. I'm Cameroonian. I'm a computer engineer, graduated in 2016 from Polytechnique Yaoundé.
Je m'appelle Abeni Gifon Marianne. Je suis camerounaise, je viens de Yaoundé, où j'ai eu un master en physique à l'université de Yaoundé 1. Et par la suite, je suis allée à l'INDE, à IMS Cameroun, où j'ai eu un master en sciences mathématiques.
My name is Abigail Anka and I'm a Ghanaian. I have a bachelor's degree in statistics and mathematics.
Je suis Awa Sanake, je viens du Mali, plus précisément de Ségou. J'ai 2 masters. Le premier, je l'ai fait en Algérie à l'Université des sciences et de la technologie Wally-Bourmédia. Et le second, je l'ai obtenu cette année, je l'ai fait à l'Université Pierre et Marie Curie.
When I finished my master, I took lots of online courses, but this wasn't enough. So I applied for this program because it was focused. And it has very diverse fields like natural language processing, computer vision, and this will help me to decide which topic I will pursue in my PhD.
I applied to this master because the content given here is both very broad and very deep. Machine intelligence is going to be a revolutionary field, maybe as big as the Industrial Revolution, and this program gives you both the knowledge and the connections to start a career in this field.
I applied for the African Masters of Machine Intelligence for 3 reasons. The first reason is that I'm a computer engineer, but I have a strong interest in mathematics and its application. And the second reason is that there is a revolution going around the world and about machine intelligence. So I wanted to be part of this revolution.
J'ai postulé pour ce master en machine intelligence parce que j'étais motivée et ce pour plusieurs raisons. Déjà, des experts venant de partout dans le monde pour nous enseigner, venant de Google, de Facebook et tout. C'est pas tous les jours qu'on rencontre ça.
I applied for this program for two reasons. First, machine intelligence seems to me as the math of statistics. With my background of statistics and mathematics, I wanted a course where I could explore the applications of the two courses at the same time.
J'ai décidé de venir ici pour approfondir mes connaissances, me perfectionner. Parce que là, les cours seront donnés par des professionnels, des experts du domaine. Et là, je ne pourrais qu'en acquérir plus pour pouvoir réaliser mes rêves.
My main objective in this program is that I want to learn the foundations of machine learning.
So I hope to gain two things mainly from this program. I hope to gain the necessary knowledge to start creating machine learning and also the connections.
Mon souhait serait de faire un PhD.
I plan to use this knowledge to interpret machine learning algorithms, to be able to use them in health informatics field, because we want a reliable diagnosing system. So this is my plan for the PhD.
My career objective is to be an applied mathematician in research and academia, where my abilities will contribute to positive social change.
By the way, this program is funded by Google and Facebook, so they can also do good things. Yeah, but seriously, the reason why I'm talking about this is this was possible only because people like you committed some of their time to help with the program. Researchers came to teach there, but I believe a critical aspect of the program. I believe a critical aspect of the program was that a lot of students around the world volunteered to mentor. And Julian was talking about donating some of your time to do something that can be impactful. I think if you have time to donate, to mentor a student, which is not that of a big commitment. In fact, you meet the students over Skype or any VC system, or you can even volunteer to come down and TA for a course. It is not a significant contribution in terms of time, but it is potentially extremely impactful. Shoot me an email, and we make this happen. Another way, of course, if you want to do research full-time on AI for social good, which is something I talked about earlier at the beginning of this talk, is just to join my team at Google. We do this full-time, and people work on fascinating problems that I did not mention, but we can talk about this, ranging from applying machine learning to agriculture, which is really a matter of food security in many places in Africa, or to analyze satellite images, which is something Julian talked about, or to predict disasters like flood prediction, or to use it in healthcare, or any of these fields. So there is potential to use what you know to positively impact the world. Use wisely your knowledge. Thank you.
Okay, so we have some time for questions for Mustafa.
If you have questions, don't be shy.
The possibility of good ideas to emerge. Like, wouldn't it be better instead of like, I understand why partnering up with
Well, this is a question I hear a lot. I think it's a legit question. But my opinion about this is that inside tech companies don't just exist as, these weird creators that we want to believe they are. Inside tech companies, people who have values work in there. And many of them genuinely believe that they can use what they do inside those companies to positively impact their communities. I mean, I work for Google, but I'm also a faculty at the African Institute of Mathematical Science. And I can tell you that in this program, half of the lecturers came either from Facebook or from Google. And you see the students who graduated from the program here. They actually don't really care whether, who these people work for. And those people were actually really busy, but decided to donate some of their time. And these companies allowed them to donate some of their time to the program. I think it's not about, black or white. It's about finding ways to give the opportunity to people and to the companies to positively contribute to society. And whenever that is possible, I will not go away from those opportunities. Yeah, I think that's my answer to this question. We are seeking partnerships. It's not just companies, it's organizations, it's universities, it can be any sort of organization. But any organization whose main goal is to positively contribute to the success of these type of programs are welcome, definitely.
I just have a comment. Goodness doesn't have to be so noble as well. Like individually, we can do simple things also to make a change.
Absolutely.
I mean, personally for me, I worked in health sector for close to 10 years. Gave up a career which paid me 6 digits. Came back and did a master's and a PhD.
Excellent.
I mean, I'm the furthest from country-wise as well. I come all the way from New Zealand. I have twins who are 5-year-olds, and I'm still here.
Excellent.
I came back to do PhD because I wanted to see change in health sector. I wanted to see how we can use technology to change. New Zealand is not a third world country, but there is still quite a lot we can do. So I kind of feel like, I mean, this is noble, but you also have to sometimes be realistic about what you can do as well. Like, I can only talk from my personal experience that I can't leave my family and go somewhere to help.
Absolutely.
But I can help from where I am.
Absolutely. Absolutely.
And it works.
Absolutely.
I mean, it's a big commitment to give up a career like that, but I still did. So I think it is possible.
Yeah, I mean, I completely agree with you. There are many ways to help, and I think the most important thing is just to feel, to contribute in a way that you feel impact. And this is one way of doing it. And not everybody obviously should be doing this. In fact, I hope people will come up with more innovative ways of impacting their communities where they are. The reason why I am publicizing this and I'm inviting people to contribute to this is because I know we have a shortage of people who have machine learning skills in the continent. And I also know that it is by far the fastest growing population in the world. I am 34 years old. And in my country, I am older than 70% of the population, 70. So actually, I'm very old. So, these, in general, in such a young population, you have both it is urgent to endow the young people with the right skills, the skills that are necessary to build critical technologies at this moment. And it happens to be machine learning today. And that's the main reason why I'm having this call. But I hope everybody can have an impact in their local communities as well. And I commend you for your courage, because it's not easy to give up a career. I tried actually once and failed, so yeah. Thank you. Other questions?
Yeah. Do you worry about, for example, people coming from Africa now getting like these top degrees and getting great skills, but
then kind of disappearing into like London, New York, like a kind of brain drain thing? Like, how do you mitigate something like that?
Well, brain drain is a myth. It doesn't exist.
Okay, well, that's what I was going to ask. Is it the problem?
Yeah. So I'm going to answer this question because I was supposed to be one of those brain drain people, you know. I was drained. But I came back. I mean, you know, I believe science doesn't know about these frontiers. I mean, when Arthur does a lecture here at UCL and puts the slides online, someone in Ghana or Accra downloads the slides. I mean, the embassies and consulates can keep my passport for some time and you know, prevent me from giving this lecture that I was supposed to give on Wednesday. I'm still angry about this, by the way. But, I mean, at the end of the day, the knowledge flows. We just need to find the right ways to make people, to give the people the opportunity to contribute back home when they want to. And my opinion actually is, if you were born somewhere and grew up there and see your community struggle for certain things, your will to give back, we are human beings. I mean, there are certain things that are natural, is so important and so strong that you always end up coming back. I did this, and many people do this. I mean, you just heard her talking about you know, how she is willing and looking forward to contribute to her community in New Zealand. Even if she said that it's not a third world country, but there are things to do in your community. So, you know, Jonas, Sarah, Lionel and all that, you are going for, I don't know, working for all these companies. But come back. Another question? Thank you.
So let's thank Mustafa again.